All right, so section 5.3b, inverse functions. We're going to start off with the theorem 5.9, the derivative of the inverse function. So first part of the definition says to let f be a function that is differentiable over the interval I. It says if f possesses an inverse function g, so they're saying like we're going to assume that it does have an inverse function. We're going to call it g. Then g is differentiable. So g is differentiable at any x for which f prime of g of x is not equal to 0, and g prime of x, which is the derivative of the inverse, because remember, g is the inverse, right? So the derivative of the inverse is 1 over f prime of g of x. Okay, and remember, this is assuming that f prime of g of x is not 0, because if it is, then that means we have a 0 in the denominator. Now, a lot of times people don't like this notation, so I'll just show you another way of doing it. F inverse prime of x is 1 over f prime of f inverse of x. So some people prefer seeing it that way. So it just kind of depends on how you learned it. This would mean that f prime of f inverse of x cannot equal to 0. I learned it the second way because sometimes they wouldn't give me like a specific letter for the inverse function. Sometimes they just say it's the inverse, so I would just write f inverse of x. But it just depends, whatever you prefer. Okay? For me, I always preferred the second one. So let me show you. We have two examples we want to try to do. Okay? But this is basically just saying if you got to take the derivative of an inverse, then you're going to basically write 1 over and then f prime of the inverse composed of that function. Okay, so you're going to compose the function first and then take the derivative of it. Okay, so here we go. Let me show you what's going to happen. Now, just a real quick reminder for you guys. So a reminder. If f of x has the point AB, then f inverse of x has BA. So if someone tells you that the inverse has a y value of 7, then that means that the original function has an x value of 7. Okay? Remember that because that's kind of important for this next problem. So, can you guys tell me what example are we on right here? 3. Okay, so example number 3 says let f of x be equal to 1/4 x cubed plus x minus 1. Part A. So for part A says, what is the value of f inverse of x when x equals 3? Okay, what is the value of f inverse of x when x equals 3? So they want to find f inverse of what? If you kind of read this, they really want me to find f inverse of 3, right? That's what they want. But that means that that's the x value for the inverse function, which makes it what? For the original? The y value, right? So f inverse of x has 3 comma b, right? Thus, f of x has a comma 3. Right? Because the x value for the inverse must be the y value for the original function. So, what I'm going to do, let's solve 3 equal to 1/4 x cubed plus x minus 1. Okay, so what I'm going to do is I'm going to multiply everything by 4 first. So let's write this out. 12 equals x cubed plus 4x minus 4. And then I'm going to move the 12 over. So 0 equals x cubed plus 4x. That would be minus 16. Now, if you use Desmos to find a graph of this function, okay? So at this point, I would use a graphing utility. I would graph the picture of this function, and I'm going to look for its x-intercept, okay? So let's go ahead and graph this thing. Now, of course, you can use your graphing calculator. I'm going to use Desmos just because of the fact that that's something that I can easily show you guys. So we have x cubed plus 4x minus 16. Okay, I know it doesn't look amazing or anything, but there's the graph. Now to find our solutions, we look for our zeros, right? So my 0 occurs at 2 comma 0. That means x equals 2. Okay, so based on the graph, we find x equal to 2 is a solution. Okay, so based on the graph, we found that x equals to 2 is a solution. So f of x has 2 comma 3. Okay, therefore f inverse of x has 3 comma 2. So when they ask me what is f inverse of 3, all I have to do is write 2. Because when you plug in the 3 into that function, the answer is 2. I'll go over this again just so you guys can kind of understand. It's kind of like a circular problem. You have to go around in a circle, right? You start off with something, you go do something else, and then based on solving that other stuff, you actually find your solution for the original stuff, right? So let me let you guys just kind of write this down. But like I told you guys, one of the things you have to be good at when you do these problems is understanding that when you're dealing with inverse functions and real functions, what you find for one can also help you with the other one. It's just kind of flipped, right? Finding an x for one is really finding a y for the other. Okay, or finding y for one is like finding x for the other. And that can be helpful in knowing that. So just really quick, this is part A. It says find f inverse of x when x equals 3. In other words, find f inverse of 3. So f inverse of 3, that's my x value for the inverse, which makes it the y value for my original function. So that's kind of what I was kind of pointing out right there in this portion of it, right? That's my y value. So once I figure out that that's my y value, and I was given f of x equals to 1/4 x cubed plus x minus 1, then my y value is 3, so I'm going to plug a 3 in there. In solving for it, so that's kind of what we did, right? We're going to solve for this thing. We ended up with a function of x cubed plus 4x minus 16 equal to 0. You can solve this analytically if you'd like to, but cubics sometimes can be kind of tough to solve. So it's nice if you can just graph it on your graphing calculator, on Desmos, something like that. So based on the graph, we saw that the root was x equal to 2. That's when it crosses the x-axis. So therefore, the point 2 comma 3 belongs to the function f of x. Well, if 2 comma 3 belongs to f of x, then 3 comma 2 belongs to f inverse of x. Well, since 3 is my x value for the inverse, then I plug it in, and then the y value is 2, so that's what I get for my solution. F inverse of 3 equals to 2. Now, for part B, they want us to find, let me write this down right here, what is the value of f inverse prime of x when x equals 3. Okay, again, what they're looking for is the derivative of the inverse of 3. That's what they're looking for. Now, if I write down the formula for this, it's supposed to be 1 over f prime of f inverse of x, but I'm going to put 3 because of the fact that I know that that's what they want me to evaluate at, right? X equal to 3. What's f inverse of 3? It's 2. We just solved that in part A, right? So I'm going to write 1 over f prime of 2. Well, the only way I can find f prime of 2 is first I got to take the derivative of the function, and then I plug in a 2. So let's do that. So let's see, f of x was 1/4 x cubed plus x minus 1. So f prime of x is 3/4 x squared plus 1. Okay, if I plug in a 2 into this function, I get 3/4 2 squared plus 1. You'll notice that the 2 squared and the 4 are going to cancel out, so all you have is a 3 plus 1. That's a 4. So f prime of 2 is equal to 4. So all I'm going to do is plug that right in there, and my answer comes out to 1/4. And there's my solution. Okay, so we're just finding out 1/4 for it. Any questions on this one? We get out of here 11:03, right? All right. So short days, always cutting time. Let me just show you this one last one. Okay, example number 4. This one actually just has a title. Graphs of inverse functions have reciprocal slopes. So whenever they tell you to graph two inverse functions, their slopes should be reciprocals. Okay, so graphs of inverse functions have reciprocal slopes. So here's a problem to kind of help you with this. Let f of x equal to x squared and f inverse of x equal to radical x. Okay, given 2, 4 and 4, 2 respectively. In other words, f of x has 2, 4 and f inverse of x has 4, 2. Okay, So given that respectively, show that the slopes of the graphs, so show that the slopes of the graphs are reciprocals. At these points. Okay, so it's just a proof. Show that they're reciprocals. So we'll start off easy. Okay? So if they want me to show slopes, then that means I got to take derivatives, right? So I have f of x equal to x squared. The derivative of f of x is 2x, and the derivative at 2, okay, is 4. All right, great. I found that my derivative at 2 is 4. That's my slope. So what am I expecting the derivative of my inverse to come out to? If it's true that the graphs of inverses are reciprocal slopes. What should be the slope of my inverse? At the point 4, 2, I guess you could say. And my first one has a slope of 4. 1/4. That's what I'm expecting. If I don't get that, I did something wrong. Okay? So, let's see. F inverse prime of x is equal to 1 over f prime of f inverse of x. Okay? So, that is my formula for this thing. Okay? So, I'm going to have to figure out what is my f inverse of x and plug that into my derivative function. Now, I know what my f inverse of x is. It's radical x, right? So let me write this down. 1 over f prime of radical x. Now, what's my derivative for my original function? Well, it's right here. This is f prime of x, right? It's 2x. So then the derivative, if my function is radical x, notice I'm just composing it, right? I'm going to use my square root to plug it into my derivative. This becomes 2 radical x. Are we okay with this? A lot of times people get lost right here. Notice I just plugged in f inverse of x into my denominator, so it became radical x. And then the denominator now says, what's the derivative of f if you plug in radical x? Well, the derivative of f was 2x. But if I plug in radical x, it's 2 radical x. Right? So this becomes 1 over 2 radical x. I should put that in green. Hold on. 1 over 2 radical x. Now, what number am I supposed to plug into it? According to the problem, 4, 2. Or just 4. That's my x value, right? So let's do f inverse prime of 4. Well, that'd be 1 over 2 radical 4. Which is 1 over 2 times 2, which is 1/4. Right? So I'm just going to put right here. So f prime of 2 is 4, and f inverse prime of 4 is 1/4. Their slopes are reciprocals. Now I'll let you guys know right now that you guys on your quiz coming up, you will have a derivative problem to do with inverses, and you will also have a proof problem to do like this. Okay? So you'll have one derivative problem for your inverse and one proof problem as well, which you have to take derivatives of anyway, but you'll have one of each. So make sure you guys understand how to do these examples. So let me see. Last time I gave you guys homework to 48, correct? The last homework assignment? So the homework for today, the rest of it is page 349. I know I write page 349 and maybe 71 through 74 are not on page 349. I just give you the original because of the fact that you might just want to add it on to the other homework that you had. It's up to you. But that's the homework, okay?